Right, so we go to Euclidean geometry. Euclidean geometry, you just basically must go to page 207 and recap all the stuff. Now, the whole thing about geometry is, what do you see? As soon as you see a straight line, you must think of angles on a straight line equal to 180. You must think of angles around a point equal to 360. You must think of vertically opposite angles. Then as soon as you see parallel lines, you must think of F, U and N. F is the corresponding angles are equal. U is the co-interior angles are equal, and N or Z is alternate angles. Co-interior angles add up to 180 and alternate angles are equal. The whole thing about geometry is, can you see what is happening and what do you apply to it? So if I see straight lines, I apply the rules of straight lines. If I see parallel lines, I apply the rules of parallel lines. If I see triangles, I apply the rules of triangles. So remember, if I only see this, then I can say the isosceles triangle. You can't make up your own thing and say the isosceles triangle, right? You can't assume anything in geometry. So here, scalene triangles, all three sides are not equal. Isosceles triangle, all two sides are equal. And those two angles that make the V, those two angles that point towards it, those two angles are equal to each other. And we say angles opposite equal sides. If I am working out the angles, I don't say opposite angles, Bashira, I say angles opposite equal sides. Or if I'm working out the sides, I say sides opposite equal angles. I swap the two terms around. Then when I go to here, equilateral triangle. If they say equilateral triangle, that means all three angles are equal to 60 degrees and all three sides are equal. If they say right angle triangle, I must know Theorem of Pythagoras straight away. I also can use, sometimes you can use trigs too, to work out geometry. You could have used trigs, it will work, right? Sum of angles of a triangle, you must remember that all three angles equal to 180. Exterior angles of a triangle, you know that C is equal to A plus B, or if I'm working at B, it's C minus A, right?
You have to use the cosine.
You never learn it yet, so you can't use it.
But we learn.
Yeah, but technically you never, so you can't.
But it's our own method of doing it.
If you want to, you can. It's fine, right? But they wouldn't have asked you a question that needs you to do it. That's the thing. They wouldn't have asked you a question. But if you feel like doing it, that method is fine. I'll take it. Right? So it says Theorem of Pythagoras. You must remember Theorem of Pythagoras. You must remember that when you're working out the hypotenuse, it's the two sides squared added together. Junaid, leave the phone now. Right, and if you're working on a side, it's the hypotenuse squared minus one of the sides squared. Congruency, you must remember congruency. When you are doing congruency, you must remember the four conditions. Now, they can tell you to prove congruency in the paper, even though we haven't done it for a very long time. How do you prove congruency? You say in this triangle and in that triangle, and you must have three proofs. So if you are going to prove all three sides are equal, you need to prove that the side on this one and the side on that one are equal to each other. And then at the end you say, therefore this is congruent to that. How do we show congruent? The three straight lines. The three straight lines vertical is similar. Then I could prove the second condition, two sides and an included angle. That means the two sides have to be like this and the angle has to be in between it. Right? That is the included angle. What?
When you write in triangle, all the points form that triangle.
Very good. When you are saying in triangle this and in triangle that, the alphabets have to correspond with each other. So if you're saying A, B, C here and you're saying D, E, F here, you can't put D on the left hand side, you can't put B on the right hand side. You need to make sure that all the triangle alphabets go with each other when you are writing it out. Okay? Then you're going to say here, condition number 3, you have a straight line and you have two angles on one line. So both of them lines are the same, but both the angles are also the same. So this is called angle side angle or angle angle side. Then you have to know condition number 4, when it's RHS, right angle hypotenuse side. Then midpoint theorem is from grade 10. Remember we learned midpoint theorem. What do we know about midpoint theorem? We know that if this is equal to that and that is equal to that, then DE is parallel to BC and DE is half of BC, or BC is twice of DE. Sorry, just somehow something, whatever, right? Or I could have, if I got this, so this one here was when both sides were broken up into midpoints. But here, if I have one midpoint and one parallel, then I can say therefore this is equal to this, and therefore this is half of that. So that's how I can prove it two ways, right? Now they love to ask this question when they want you to prove that they are parallel lines. Okay, they want you to prove that this and this are parallel lines. Right. Properties of quadrilaterals, you need to remember your properties of quadrilaterals. Sometimes they'll tell you prove that this quadrilateral is a parallelogram. Prove that this quadrilateral is a rhombus, etc. So when you go here, it tells you when you need to prove, what do you need to prove? In order to prove, right, you only need to, that's what I'm going to show you here. Say, in order to prove that a quadrilateral is a parallelogram, you need to prove one of these conditions. One of the conditions is opposite sides are parallel, or opposite sides are equal, or diagonals bisect, or opposite angles are equal. Or you need to prove that one pair is equal and parallel to each other. That's the one where you have to prove that one side, both of them are equal and both of them are parallel. If both of them are equal and both of them are parallel, then automatically these two would be working out same. Right. Then if you go to page 210, it also tells you how to prove that something is a rectangle. In order for you to prove that a quadrilateral is a rectangle, you first need to prove that it's a parallelogram. After proving that it's a parallelogram, you can prove that one of the sides, all the sides are 90. And therefore, or you could prove that the diagonals of the quadrilaterals are equal in length and bisect each other, then therefore it's a rectangle. Why? Because that's a special property of a rectangle. For a rhombus, if you prove all four sides are equal, but it's also a parallelogram. So you must remember, when you're proving that something is a rhombus, you first have to say it's a parallelogram. If they didn't tell you it's a parallelogram, you had to prove that it's a parallelogram and then prove it's a rhombus. Right? Or you can prove that the diagonals bisect at right angle, bisect each other at right angles, so they intersect in the middle at 90 degrees. Square, you can prove all the properties. Any of these properties, you would have gotten the same answer for it. Right, trapezium. Right, trapezium, how do you prove if something is a trapezium if only one pair of opposite sides are parallel? Okay. A kite, how do you prove that something is a kite? If the adjacent sides are equal to each other. So if they give you the length of this and they tell you work out the length of that, and you prove that this and this are the same, and you prove that that and that are the same, then you can say this is a kite. So you need to prove that the pairs of the adjacent sides are equal in length. Right? You need to know the terminology of a circle. What's a tangent? Now tangent you don't need to know for this exam, you need to know for the end of the year. A secant is when it's a chord that's extending outside of a circle. A diameter goes through the center. A radius is from the center to the circumference. This whole thing is called a circumference. An arc is between 2 points on the circumference. A segment is a part that's in between a chord and the circumference. A sector is between two radius. Can you see? One radius, that's a sector. A sector is a portion between two radius, okay? Right, now, every single year, they ask you for the first question to prove one of the theorems. They ask you to prove one of the theorems. Who has a booklet here for me quickly? Right, pass me a booklet. The reason why I gave you the booklet is because the booklet tells you this will be asked in the exam. They never ever gave us in maths multiple choice. They only give in physical science. Oh, they used to give you in grade 9, nah? Yeah. Right. If you go to theorem 1. Right. You see here, in theorem 1 in your booklet, it said theorem 1 proof can be asked in an exam. And if you go for the past 5 years, they always ask the same one. So you need to go to your booklet on page 12, your booklet on page 12, and learn this off by heart. When I say off by heart, they'll give you one like this. They won't give you the perforated lines. You'll have to learn the whole thing. Given, required to prove. How do I prove? First say join. Then find, this is where you do congruency. That's where they test you the congruency through the proof. Can you see how they test you the congruency? Through the proof. So you have to prove that this triangle and that triangle are equal to each other. And because they are equal to each other, they are congruent to each other, then therefore AM is equal to MB. And that's how you prove the first theorem. And what's the first theorem? The first theorem is that a perpendicular line drawn from the center to the midpoint of a chord bisects the chord. Isn't that the theorem? Also, it's also a perpendicular line. A line from the center to the midpoint makes a perpendicular angle there. So this is called perpendicular from center to chord. That's how you prove that this is equal to that. Right. The second part says may not be asked in an exam, so they won't show you this part here. But this one here is showing you that if you have this equal to this, and this is the center going to the midpoint, then therefore M1 and M2 has to be 90 degrees. Okay. Right. That's called the converse of theorem number 1. Then it goes to 1B. Now 1B not going to be asked in the exam. But let's apply the rules. So whenever you have to apply the rules, whenever you have, now this is how you remember the 4 rules. The first one is the perpendicular line from the center to the midpoint will bisect the line. So if you have a perpendicular line and you have a center, then you know that it's going to be bisecting the line. Those are clues. Then you're like, okay, I need to do this. Right, the second one, theorem number 2. Now theorem number 2 is angle at the center is equal to twice the angle at circumference. Now they can ask you any one of this. If they are asking you the picture of A and B, right, if they are asking you the picture of, not A and B, if they are asking you the picture of A and C, then you learn the first proof here. Right. Then if they are asking you B, you have to learn the second proof for it. So the whole proof is just about learning about exterior angles of a triangle. What they would have done is they would have separated this in half. They would have made a line in the middle here. Right, here they would have made a line also. They would have showed you here how they made the line, and then they would have found similar triangles, and therefore they would have proved it. Okay, that's the whole thing. You just have to learn this. So they love to ask angle at the center and the first theorem. They ask the proof of that. Right, so how do we know the angle at the center is equal to twice the angle of circumference? You take 2 points. If you can go towards the center and come back and go towards the circumference, then that's angle at the center. Okay, so this one here, also I can go towards the center, come back, go towards the circumference. But this one here is the opposite. This one here is where you have to find the reflex angle. So here I'm going towards here, but I'm going forward. Now these two was going in the same direction, but this is going backwards and then going front. Or it can go front and then go backwards. See, this one's going front and going front. This one here is going front and going front. This one here is going in 2 different directions. So you need to know that the angle that you're working out is not this angle here, it's the opposite angle there. Right, that's a very important thing to remember. Right, so if you go for the example here, 130, so therefore that is half of 130, which is 65. Now look at this one, towards the center, come back, goes towards there, so that and that is 50. And then this one here, if I'm going there and I'm coming back and I'm going there, it's the angle on the outside. Okay, so half of 270 is 135. That's how I would have gotten this. Then you have to go to theorem number 3. Now theorem number 3 is very important because in your assignment, many of you got it wrong. You have to highlight the diameter. When you highlight the diameter, this is 90 degrees, not the corner here. Some people were saying this is 90 degrees here. It's not 90 degrees here. These two are not 90 degrees. Only that angle there. Why? Because of angle at the center is equal to twice the angle at circumference. Can you see here? I'm going towards my center, I'm coming back, I'm going towards the circumference. Because this is 180, then this one here must be 90. They say it may not be asked in the exam, but I saw in one exam paper they asked this question, right? And this one here was all about angle at the center equal to twice the angle at the circumference. But what is this one called? It's called, what's called angle in a semicircle or angle in half a circle. It's exactly the same. Right, how do you prove that something's a diameter? If you can prove, so look here, how do you prove that this is AB is a diameter? If this is 90 and this is AB and the chord subtends 90 degrees, then therefore this is a diameter. Now, some of you are using the wrong wording. You only use this wording if you are proving that this is a diameter. You have to use this reason if you are proving that this is 90 degrees. So you need to go back and say, which one am I using? Am I using it for the diameter or am I using it for the 90 degrees? When you want to work out the 90 degrees, you have to say angle in a semicircle. When you want to work out that it's a diameter, you must use chord subtends at 90. Okay, same thing with the other two before. Then you go to theorem number 4. Now theorem number 4 is the bow tie or angles in the same segment or chords in the same segment, right? So what's going to happen? This one here you don't need to prove, but you need to know arc or chord subtends equal angles or angles in the same segment. So let's go here, right? So this goes there and this goes there. Therefore x and 20 are equal to each other because which arc? MN subtends equal angles. If I want to work out y, I have to go this way here. This, go back, this. So y and 15 are equal to each other because arc LP subtends equal angles. What do you mean smaller?
One triangle is smaller. It's not always
No. Yeah, it doesn't have to be exactly the same size. It's true. Right. Then you go here. These are all exactly the same things. Right. Now this one here, people will be getting confused and be, what the hell? This was angle at the, what is this one? Angle at the center. Right. Now the polarities on theorem 4, which I was calling theorem 5, but this is called the polarities. You need to remember this. That if I have the same chord and I have the same chord, they're in the same circle, the angles will be the same at the circumference. They would both give me the same angle. If I have, this is the center, I told you to make a dot here and remember that this is called the center, so we call it O. It's the center. Right, this is the center. If I have a chord there and I have a chord there that are equal and they come towards the center, then the opposite here will be equal. Not because of vertically opposite, because of equal chords subtend equal angles at the circumference. Can you see that? Then we say, when you have one circle and another circle that are exactly the same in size, and this chord in one circle and this chord in the other circle are the same, then therefore the two angles will be the same also. That's all the rules you had to learn for geometry. All of you got it now? Everyone's fine? Now, the thing about geometry is you have to see. Now all of you take your question paper. Take your question paper that I gave you to go and look at. Take your question paper. You got 3.1 and you got 3.2.
What paper is that?
The one I just gave you now, your assignment, man. Right. Go to question 3.1 and 3.2. And I'm giving you, it says here 18 marks. I'm giving you 10 minutes by yourself to answer both of them. Okay? Some of you got full marks for 3.2, but I want you to do it and write the proper reasons this time. Okay? I'm putting the timer on. Are you ready? You can look in your textbook, whatever, but don't talk because I want you to understand your own. The whole thing about geometry is if you see a center, what must you do? If you see a radius, what must I do? If I see a straight line, what must I do? Etc., etc., etc.
Oh no, this one goes to theorem 4. So
Yeah, because you only need to know that for this paper.
but you said you have to know until theorem 5.
What did I just tell you? I called theorem 5 the bottom part, but it's not theorem 5.
This one.
Yeah, I called it. I called it that, but it's not theorem 5. I just called it theorem 5, but it wasn't theorem 5. It was just it's an extension of theorem 4. There's only 4 theorems you need to know. Right, you're starting. Come now. Do it on your own, do it on your own. Do 3.1 again. And don't assume things, because some of you were assuming weird things, huh? Like you were saying that angle G is X. How can you just assume that angle G is X if you're not proving it properly? Now remember, the whole thing of geometry is turn it. Whenever you're looking at something, keep on turning the page. Also, if you see radius, make the marks of a radius.
When I did that, you told me I can't use that.
I said you can use radius, but you were using it in the wrong way. You can't assume that two isosceles triangles are the same. They're not the same.
Never said they the same.
Some people were doing that. They were saying, look
I
here.
was saying the angles
Some of
are
you,
the same.
no. That means the same thing you just said now. They're
No.
not the same. Look, some of you told me this is an isosceles triangle. then these two things made an isosceles triangle. Therefore, if this is x and x, and these two are x and x. I said leave the answer in terms of x. That means every single answer will have x in it.